Today we're going to practice using integration by parts when you're trying to evaluate an integrand with a single term. Okay, so our first example has, of course, a single term. The single term in our integrand is arc sine of x, right? So we've just got arc sine of x to work with. And the key here is that we're still doing integration by parts. So our first step is to try to choose u and dv. When you're integrating with a single term for your integrand, the first thing to try is simply to have
It's 15:45.
u equal to your integrand. So here u would be equal to arc sine of x, and dv would be equal to dx. Now, that's step one, is to make a choice. Step two is to fill in the rest of our chart here. What's du and what's v? Well, if dv is equal to dx, then v must be x. And if u is arc sine of x, then du is, I don't remember. What is the derivative of arc sine of x? It is 1 minus x squared. Take the square root and take the reciprocal. All right. So now let's go ahead and go to step 3, which is going to be to say my integral of arc sine of x dx is equal to, this is my formula, uv minus the integral of v du, right? My u is arc sine of x, v is x, okay, so I need to put an x there, minus the integral of v which is x, and my du is, critical error. This is du is 1 over this dx. Wow. So sorry about that. So I'm going to change this to 1 over the square root of 1 minus x squared. All of that times dx. Okay. So let's rewrite this, and I'm going to write this first product as x arc sine x. And now minus the integral of x over the square root of 1 minus x squared dx. Now, is my trade-off worth it? I started off with arc sine of x, needing to integrate that. Now I need to integrate x over the square root of 1 minus x squared. It might look like this is worse, but actually this is better because I can do a u substitution and figure this out. So I'm going to do a u substitution. I'm going to let u equal 1 minus x squared. Du is going to be negative 2x dx. So my original integral is going to turn into the integral of x over 1 minus x squared square root dx. It's going to be equal to the integral. And on the bottom here, I'm going to have the square root of u. And on top, this x dx looks like that's going to be 1/2 du. You see, if I divide this by negative 2, then the negative 2's cancel out. And so I should have x dx is equal to negative du over 2. So let's put that here. So I'm going to have negative 1/2 du. And now to figure out this integral, I'm going to rewrite my integral as negative 1/2 times the integral u to the negative 1/2 du. Go. No. Now I use my power rule. I add 1 to my exponent, divide by my new exponent, and add a constant. I still have this factor of negative 1/2 out front. And so this, the 2 and the 1/2 will cancel each other out. So I'll just have negative square root of u plus c. But remember, u was 1 minus x squared. So I'll have negative square root 1 minus x squared plus a constant. So for my final answer, equals x arc sine x minus negative, so it's going to turn into plus square root of 1 minus x squared plus a constant.